So the last thing that we talked about were neurotransmitters, and today we're going to be talking about hormones, which are really similar to neurotransmitters. Sections 18.9 and 18.10, we're going to talk about epinephrine and histamine, which are two types of hormones, and we're talking about them in chapter 18 because they are both amines. There are other hormones, and we've talked about other hormones as well. So let's first talk about what a hormone is. What's the definition of a hormone? It's a biologically synthesized molecule, so that means that we produce it in our body. They can also be synthetically made as well. And the purpose of a hormone is that it transmits messages from our brain to different organs. Depending on what the hormone is, it could go to any one of our organs, and it sends a message from the brain to the organ for the organ to do something in particular. So first we're going to talk about epinephrine. Epinephrine is also known as adrenaline. So you've heard of adrenaline before. Epinephrine and adrenaline are the same thing. And as I'm sure you know from the term adrenaline rush, which we've all felt, epinephrine is synthesized in our body when we believe that we might be in danger. So in response to the perception of danger, we convert this molecule, norepinephrine, into epinephrine. And epinephrine is useful in a dangerous situation because, as I'm sure you know, it increases our heart rate and increases our blood pressure. And so our heart is beating faster. It increases our rate of respiration, and it increases the efficiency of oxygen absorption during the respiration process. And it helps us make glucose. And all of these things get us ready for either fighting or fleeing in the fight or flight response. There are a lot of synthetic drugs that are similar to epinephrine. So up here, this is the structure of epinephrine as we synthesize it in our body. And then here are 5 pharmaceuticals that are all very structurally similar, not identical, but structurally similar to epinephrine. Starting with amphetamine, not to be confused with methamphetamine. So methamphetamine, as far as I know, doesn't have any legitimate purposes. It's just a straight drug. Amphetamine is an ADHD medication. It's not the only ADHD medication, but it's one of them. And it also has been used as a weight loss drug. I don't know if it's still being used for weight loss purposes. And again, it's not the only weight loss drug out there. There are, of course, controversies associated with prescribing amphetamines to people. This pseudoephedrine we've talked about before. So pseudoephedrine is the active ingredient in Sudafed, the real Sudafed, the stuff that you have to go to a pharmacy to buy. You don't need a prescription for it, but you have to ask a pharmacist for it. Pseudoephedrine is very easily converted into methamphetamine. If you look at the two structures, the difference between pseudoephedrine is just this OH group. And so all you have to do is remove that OH group to convert pseudoephedrine to methamphetamine. And that's very easy for people to do at home, which is why pseudoephedrine is under control. Phenylephrine, this is the active ingredient in Sudafed PE, which is the Sudafed that you can purchase over the counter that you don't need to go to the pharmacy for. Sudafed PE is quite a bit different from methamphetamine. So it's missing a functional group right here. It's got this extra functional group right here, and of course the extra functional group right here. So it takes quite a few steps to convert phenylephrine into methamphetamine. And so far, the at-home drug dealing chemists have not figured out how to do that conversion yet, which is why Sudafed PE is available without any sort of restrictions, but it's not as effective as a decongestant as real Sudafed. And then last but not least, we have albuterol. Albuterol is a bronchodilator. It's an asthma medication, and it's very similar to epinephrine, but unlike epinephrine, it doesn't have an effect on the person's heart rate. So they can use albuterol as a allergy medication without having that sort of side effect. So that's epinephrine. Now we're going to talk about histamine. This is hormone number 2. Histamine is a hormone that we produce when we're hurt or when we have an infection or in response to an allergy. And this is where most of us, especially this time of year, are really feeling our histamines. Histamine ultimately increases our blood flow, and that's pretty much all that it does. But, we don't all, but most of us suffer from allergies, and they're annoying. So we take antihistamines. And what an antihistamine does is that it just blocks the histamine receptors. So it kind of stops that histamine response. Remember, we've already talked about receptors before when we were talking about nicotine and caffeine. So the receptor is like a parking lot or a parking spot for different molecules. There are these histamine receptors or histamine parking spots. And in order for us to have an allergic reaction, our body produces histamines and then moves those histamines into the receptor sites. And when the histamines fit into the receptor sites, we feel allergies, what we describe as allergies. Antihistamines come along and they sit in those parking spots. An antihistamine sitting in those parking spots does not make us feel allergies. And now these histamines that our body is producing, they have nowhere to go. So we don't experience the symptoms, or we don't experience the same severity of symptoms as we would without the antihistamine. See, you've probably, if you're an allergy sufferer, you've probably either accidentally used or been cautiously warned to stay away from anti-allergy medication that causes drowsiness. So you want to only purchase non-drowsy antihistamines. The reason for this is that inside of our brain, we have histamine receptors. Have like a different purpose when they're inside of our brain. So in our brain, when we slide histamine receptors or histamines into their receptors, this causes us to feel awake. We're wide awake and we're ready for our day. So if an antihistamine gets into your brain and the antihistamines block the absorption of histamine, then, as you know, we feel sleepy and tired, and that is why the not non-drowsy, that's a double negative, the regular allergy medication makes us so tired because it enters our brain. So when you're shopping for a non-drowsy allergy medication, basically you're shopping for one that cannot get into your brain, and therefore it doesn't interfere with your brain's absorption of histamines. So the last thing I want to talk about is just kind of wrapping up these last couple of lectures. What's the difference between a hormone and a neurotransmitter? Actually, I want to move this one over. So a hormone and neurotransmitters, because they're pretty similar. Hormones, which is what we talked about in these last two sections, 18.9 and 18.10, and neurotransmitters, which we talked about in 18.8. So how are they different? First of all, they're different in terms of where they are made or what part of our body produces them. Neurotransmitters are made by our nervous system, our central nervous system, CNS, whereas hormones are produced by our endocrine system. Kind of a cyclic definition there, but the endocrine system is the system of our body that produces hormones. And they travel different lengths throughout our body. So our hormones travel through the blood, and they go far. They go from our brain all the way to some other organ. Neurotransmitters travel through our neurons, and they don't travel far. They just go from one neuron to the next one. So they have just a really short path. They only cross through that empty space between the neurons. So they have a short distance to travel. Both hormones and neurotransmitters are messengers. So they're sending messages from one part of our body to another. The hormones are messengers of our endocrine system. Neurotransmitters are messengers of our brain. So they carry messages from our brain. And in terms of what do they have in common, how are they the same? Really, the only way that they're the same is just in terms of the way that they bind to a receptor. That's how they get their message across. So that I'm trying to find a way to extend that for both of them. Both of them bind to receptors, and that's how their message is received.